Okay, so this is something I've been wanting to play with, doing a video for quite a while, and it's like 10 years behind me of number theory, recreational number theory play that involves geometry. And some of you have had the privilege of sitting with me and cardboard triangles and showing you this kind of representation of fractal nature within geometry. And for me, it definitely opens up this 3D spatial awareness part of my brain, which in otherwise in normal day life doesn't really come out like it does with this. So I'm just going to show and see if the way that I talk about it is interesting, at least as a first run for maybe exploring further, because this is just scratching the surface of what can be looked at from something as simple as super cool little magnetic balls and sticks. This was like the best birthday gift anyone could have thought of for me, and I'm honoured that I received these, and then I bought a load more. The story behind buying a load more is because you get a certain number of balls and sticks. I was lucky enough to get 3 packs, these boxes that were from Instagram and Facebook advertised, and I got to the point that I was trying to make a certain shape, which will be another video. And to figure out how many pieces I needed to figure out how these are made. Well, this is the first order tetrahedron, right? Symbolizes fire, according to Pythagoras or Plato, I think Pythagoras. And the second order, without going into too much detail because the video will be too long, and I'm still learning how to talk about this, is this dude. So it's kind of just like one scale up. And once you scale it up, I'm just going to show you because talking about it is quite weird. If you if you remove the vertices of a tetrahedron, I burped a little bit there, sorry. What you get is another shape in the middle, just sitting there. Still made up with equilateral triangles. Dook. Right, so like you can see loads of different things, different angles. Some of you will know that's an octahedron, half of which is a pyramid, like a square-based pyramid. Which is cool for me. I like it because inside one shape is another. So once you've got this one, you can scale it up as well to the second order, which is like one scale bigger. Like we went from the small tetrahedron to the second size one. Over here. Oh, I'm going to screw up if I hold it. Right, so over here, you've got this bad boy, which is octahedron scaled up, second order. Lots of cool things, even with the light behind it, you can see shadows quite nicely of the lines. And yeah, so what I kind of do with people on this is just to kind of get that concept of fractal, that within one thing is itself again. And it almost is like the question, what came first, the chicken or the egg? Because what came first, the tetrahedron or the octahedron? Because we found inside the tetrahedron this guy once we've removed the vertices. With this dude, it's gonna fall apart. With this dude, if we also remove the vertices, it's fiddly work. Gotta be patient with this. Maybe I should learn some video editing to speed this whole process up. If you can imagine that this base is the pyramid, what I'm trying to point out is that we've got in each corner these mini octahedrons, the little ones, just sitting in each corner. But in between the gaps, in between the spaces between the pyramids, are these tetrahedri. Like there's 1, 2, 3, 4 sitting in here in the space in between. I'm wondering if anyone can recognize what I'm blabbering about. See that dude there? That's a tetrahedron filling the space. So really in short, and it's still 5 minutes, which is long, and I don't know how interesting I've made it sound, because for me, the interest is in the math inside it when you count how many you need to go bigger of the balls and the sticks, and what the composition is of the tetrahedri and octahedri, that within each shape is each shape. So I don't know which one's first and if it matters. But what's kind of cool is that when you keep removing... So you've got the fractal concept displayed there, shown there. And the math is just... like the equations for the expansion of it, as you scale up, it's something that I've got a load of Excel files on exploring, and somehow some of you have even come up with your own equations of figuring it out. Got some nice memories of times with people who explored it with pen and paper with me. But this thing you get as a result of removing the vertices, again, but of the octahedron, is this shape called the vector equilibrium, which Buckminster Fuller talked about quite nicely. I'm not even going to attempt to explain what's cool about it, other than that, compared to these other shapes, when you scale them up, the central point has all these lines out to every vertex that's on the outside. It's got squares, it's got triangles, and it's got hexagons as well. If you can see from that angle, we've got like hexagon, maybe you can see horizontally going around, that's a hexagon. But if I twist it without damaging it and doing it while on camera, you've got hexagons there again. Hexagons, honeycombs, bees, nature, this almost like harmonic, balanced shape that exists as, I guess, an observational point of view between points of equal distance relative to each other. Yeah, it's cool. And so, I mean, as I said at the beginning, like I wanted to calculate how many pieces I would need to make the second order one of these. And I figured that out, and I ordered more boxes, and I did it, and it was pretty epic shape to build because it's quite fiddly. I have quite fat hands. And this shape, when it's scaled up, for those of you who like such things, it's really geeky, but the way it balances and the numbers 369 that are all through it, for those of you who are interested in that field of thought, respective of Tesla, energy, vibration, frequency, 369, you know, you can't help but be curious, because the composition of these things to form this harmonic state, of which there can be infinite combinations and variations of the lengths, the angles, and the volume and scale. This is just the one that fits as it does. And I find that pretty special. Among other things, which, wow. With having quit my job and thinking what I want to do with time, there's so many things I really, really want to do. And yeah, follow your heart, right, in some directions, and some opportunities are there to combine doing things I like with my hands outside and people I want to be with, and talking about this and sharing it with people. So first attempt of putting something out to see just if, because I haven't seen video of this and I've been looking for a while. I've been looking for the equations of the combinations of composition of these shapes within each other, and thus far not really finding anything. And I'm relatively good with Google in searching for stuff. So yeah, I don't know anybody around me in Bratislava that's interested in these things, and that's that really. What do you reckon? Interesting? Curious? Hit me up.